Hey, amazing fifth grade math teachers. Welcome back to our weekly preview. This time it's for content for the week of October 17th. All right, so Monday and Tuesday are going to be flex days for ITBS testing, which means you won't have a math lesson for that day. If you have the time, it would be great if you still did some problem solving and maybe a number talk or your spiraling review, but there's no actual math lesson for those 2 days. Wednesday, Thursday, and Friday, however, we have the same lesson over a really important topic, 5.3e and a. And so we're actually going to be multiplying decimals using the standard algorithm, and we're going to apply estimation to help us determine decimal placement. Okay? So 5.3e, solve for products of decimals to the hundredths, including situations involving money, using strategies based on place value understandings, properties of operations, and the relationship to the multiplication of whole numbers. This has been tested 10 times since 2016. 8 of those times have been one-step problems. Hallelujah, right? Finally, some one-step problems. And so that's what we're going to focus on the most within this TEK. However, there have been 2 times that it's been tested as a multi-step problem, and 2 of the one-step problems have been multiplying 2 decimals. Typically, it's multiplying a whole number by a decimal, but there have been 2 questions where they multiply 2 decimals together. And then for the 5.3a, that's where we're going to estimate first before we solve, and that's going to help us decide where to put our decimals. Now, this is also a TEK where we estimate to determine solutions of mathematical and real-world problems involving addition, subtraction, multiplication, or division, and it's actually been tested 2 times with multiplying decimals, so we're kind of getting a double whammy there, which is great. Okay, so what does it look like on STAR? We'll be teaching students to estimate first to help with decimal placement. For example, let's look at this question from 2018. If students estimated first, they would multiply 7 times 20 and get 140. Basically, what we're going to do is we're only going to estimate on the decimal, rounding it to the nearest whole number. And then if there's a whole number, we're just going to leave it the same. So 20 times 7 is 140. Now let's look at these answer choices. Are any of these answer choices close to 140? Okay, yeah, this one's close. This one's actually kind of close, so I'm not going to take that one out yet. But A and C, I'm like, no. Look at how many of our students in the state of Texas chose A, 20% of them. Okay, and I want you to notice, it looks like this is similar to this, but which one is closer to our estimate? Okay, so Nancy Crouch taught us this a while back, and she said you could almost do this problem and not even do any of the math, just estimate, right? But we want to make sure we actually do the math as well, because it doesn't always work out that way. So when we multiply 7 and 5/100ths times 20, we end up with the digits 141 and 00, right? So how could I place my decimal so that it's close to my estimate of 140? That's right, 141. And look at how close that is to our estimate. But can you see these students right here? They knew how to multiply. They just didn't know where to place their decimal, and they weren't thinking about any type of reasonableness, okay? So keep that in mind. Estimate first, always, and then use that to help you place your decimal. Now, estimating doesn't always help within our given choices. For example, in 2018, number 25, if we estimate, we get 16 times 2, which is 32. So we have an electronic book that has a file size of 2 4/10 megabytes. What is the file size in megabytes of 16 of these electronic books, right? So we are estimating 16 times 2, which is 32. We have 2 very close answers and another that's also pretty close too. We know that the answer should be more than our estimate. Why? Because when we estimated times 2, and 2 4/10 is more than 2. So our answer should be more than 32, shouldn't it? Okay, in this one, obviously A and C look correct, but then D looks like it's kind of close too. So let's do the math. So sorry. So when we multiply, we would get the answer with the digits being 3, 8, 4. Okay, which one of these is close to our estimate of 32? Right? It would be 38 and 4/10. This would be our estimate. This would be our actual answer. But we know where to put the decimal because 384 makes no sense, does it? What about 3 and 8400ths? That doesn't make any sense if our estimate is 32. See where we're going with this? Okay. In this next example, Mia's dog weighs 32 and 6/10 pounds. Letty's dog weighs 3 and 8/10 times as much as Mia's dog. What does Letty's dog weigh in pounds? Ooh, this right here. Do we do this a lot in problem solving? That might be some good problem solving for the week, is doing something weighs how many times as much as Mia's dog. Ooh, that's a good one. Okay, so when I look at this one, we have a decimal times a decimal. But again, if we estimate, part of the work is done for us. So let's estimate 33 right here times 4 right here, which are both more than our actual numbers. But 33 times 4 is 132. There's only one answer choice that's even close to 132, isn't there? And so we estimated and got 132. When we actually do the work, these are the digits that come up, right? So where does it make sense for us to place our decimal when our estimate is 132? If we put it here, then our answer is 1, right? Or close to 1. If we put our decimal here, our answer is 12 and 388 thousandths. Is our estimate close to 12? No. If we put our decimal here, 123 and 88 hundredths, that's actually pretty close to 132. And so that's our answer. Okay, how we teach it. One of the things we want to make sure that students don't have the misconception of is this right here. When multiplying decimals, you don't line up the decimals. Okay, that's going to be something that's a misconception for our students. So we are definitely going to talk about that. There is a video in your Google Slides right here, okay? And it's in your Google Slides in your lesson. This video it says this is where you insert your teach piece in the lesson, but this information for you is on how you will teach it. Obviously, you're getting that from us through this video as well. But every time we're going to estimate first. Look at her. She's estimating also. And then we're going to solve, and that's going to tell us where our decimal goes. I believe in this video or in the next one, it also tells like, oh, it's one place over, it's one place over, so I'm going to go over 2 places. But the estimating really helps with the reasonableness and making it make sense, doesn't it? Okay, so how we teach it, I'm not going to make you watch the video now. You can do that on your own time. So in our Google Slides, we have it and we look like this. We have a notes page. You'll see this. And so students have a note page with step-by-step instructions on how to multiply decimals with a standard algorithm. We're reminding them it's just like multiplying whole numbers, right? So we don't have to line anything up as far as decimals. We're just going to multiply it just like we do whole numbers. But we're going to do a few things first. Our number 1 step is to estimate a reasonable solution by rounding to the nearest whole number. Okay, so that's the first thing we're going to do when we look at this question. Scott drank 3 5/10 bottles of water yesterday. Each bottle contained 1 2/10 pints of water. What was the number of pints of water Scott drank yesterday? So our first step is to estimate. So we're going to change this to 4 and change this to 1. Ooh, that's hard to estimate. 4 times 1 is 4. So our answer should be close to 4. Now I'm looking over here at these. All 3 of these are pretty close to 4 except for this one. So right away I know D is not the answer. The next step is to remove the decimal points in our minds from the problem to find the product with no decimals, okay? So we're going to do that. And so here's my product with no decimals. 44, it looks like it says 42, which is an answer choice, but I know my estimate has to be close to 4, right? And so where does it make sense to put my decimal based on what my estimate was? And so that's step number 3. Refer back to your estimate from step 1 and reinsert the decimal in a reasonable position. And so here it is, 4 2/10 is really close to 4. So that B should be my answer. And then check the decimal place. I can't see the bottom of my sheet. And just make sure that your answer is reasonable and makes sense. Okay, if you have any questions on how to teach multiplying decimals and estimating to help with decimal placement, please send me an email, give me a call. Also, if you have any other questions about any other thing with math, like maybe you weren't trained on Number Talks and you would like me to come out and work with you a little bit on that and show you where the videos are in your book for that as well, I'd be happy to come out and help with anything you need. Just send me an email or give me a call at extension 28705. Thanks so much, and we'll see you again next week.